Hey everyone, welcome back to another video on the development of Jugglebot. I'm very excited about this video because it shows a pretty important upgrade that I'm making from the old design to the current design. Specifically, we're going to be going over the joints that attach the legs to the platform. I think to understand why these joints are the way they are right now, it's worth going back to revisit the old designs that I had to see why they didn't work. The very first design that I had for this component consisted of some ball joints that I just bought online. And these joints were decent, they're very cheap, they're very easy to use, but they have a very limited range of motion. They can only move, I think it's like 50 degrees or something before they hit their end in any direction. And that's pretty annoying. That's very, very limiting. Because of this limited range of motion, I had to be really careful with where I was positioning them, and if I made any changes to the rest of the platform, I would have to go back and change the angle where these cup parts attached onto this printed part. And I forgot to do that a couple times, and it meant I just had to keep reprinting parts, and it was really annoying. So the limited range of motion really killed these for me, and they made them not really an option. Moving on from that, the next design that I had was these universal joints that I designed. And I think they look pretty cool, but they have some pretty big problems as well. The main one is that this part here is very small and is not super strong after it's printed. And one of these actually broke in my testing of Jugglebot, and I don't want to have to keep reprinting everything to make it all work. Another big problem was that it's not really that modular. Like if I'm putting the platform part onto the rest of the legs, it's really tedious to have to screw up all of these bolts and do them one at a time. It's very slow and kind of hard to hold everything at the same time because there's 6 things that all kind of want to go in different directions, and it's annoying to have to hold them all. This design definitely was better than the original one because it has a huge range of motion. Like these joints can go in any direction that I want them to, but their limited strength is a bit of a weakness, and the fact that they're not very modular was pretty annoying, and I would prefer to move out of that if I can. So the earlier designs, one of them didn't have enough range of motion, one of them kept breaking, and they're both pretty annoying to separate from the rest of the design, and the second design had way too many parts. Before jumping into my new design, it's worth going over what the design requirements of this part are so that we can see what it actually needs to do. The first one is that it has to be able to support 3 degrees of freedom. Now this might sound a bit cryptic, but all that it means is that the platform up here needs to be able to move relative to the leg in 3 ways. And these 3 ways are the 3 rotations. So if I can drag this around, if it plays nice, it needs to be able to rotate that way and that way. This is a little bit messy, but hopefully you get the idea. And that way. If it can't rotate in all of these ways, then the mechanism will get jammed up in some positions and something will break. So it needs to be able to rotate in all directions. The second design requirement is that it needs to have a really wide range of motion. I want Jugglebot to be able to move as far as it possibly can, and to do that, the joints themselves need to be able to move as far as possible. The third design requirement is that they must be easy to disassemble, and by this I mean easy to remove from the platform. I would like to be able to separate the platform from Jugglebot very, very easily, and to make any changes that I need to make without having to screw and unscrew everything. That was really frustrating with the old design. Finally, this joint needs to have a solid and strong connection that is very smooth. If the joint is gritty at all, then it will impede the motion of Jugglebot and it will make it harder to control where it's going. So I need this joint to be really, really smooth so that as Jugglebot moves around, the joints just slide nicely and allow that motion to happen. It would also be quite nice if this component had as few parts as possible, because more parts is more effort. And effort is bad. So that brings us to my new design, which looks like this. And you can see already that this is far, far simpler than the previous design. So here, all that we've got is we've got a bolt that comes through the printed part that's held on with a nut. That bolt screws into a metal ball with some thread. And then that ball is attached with a magnet to the leg. So this can just stick and unstick. And if you see here, it's very easy to separate it and attach it. This joint moves super smoothly. There's really not much stopping it from sliding around, and it ticks all the boxes. super wide range of motion. This can go really far in all directions. It's great. To give this design an objective comparison with the old design, we can do a part count comparison. And we can see the old universal joints have 19.5 parts per leg, including all the bolts and the bearings and everything, which means that in total, between the 6 legs, there are 117 parts, which is nuts. Compared to the new one, where there's only 6.5 parts per leg, meaning that there's in total only 39 parts between all 6 legs. So this means we have a 3x reduction in the number of parts that are needed for this component, which is fantastic in my mind. I'm very, very happy with that. So this is all well and good, but does it actually meet all of the design requirements? The first is that it needs to support 3 degrees of freedom. And we can see pretty easily, just by holding it and moving it around, it can twist. So that's 1. It can move this way, and it can move the other way. All 3. It's a ball in a socket. Done. The second is that it needs to have a wide range of motion. As we've already seen, it has an extremely wide range of motion. Third, it needs to be easy to disassemble, and it's a magnet. It's about as easy as it gets. And the fourth is that it needs to have a solid and smooth connection. As for the solidity of this connection, it's definitely not as solid as the previous design was, because that was all like hardware parts that were bonded to each other. And so this one can be removed, but it's fairly strong, and I think it will be strong enough. I am not a Stewart platform expert, but I'm pretty confident that all of the forces that are going inside the legs are purely in the direction of the leg. So there should be very little force acting to separate this magnet from the leg. So I think that 450 grams-ish of force should be more than enough. As for the smoothness, this joint is fairly smooth as it is, but just in case it isn't smooth enough and it does cause some like friction problems, I've bought some PTFE sheet that I might be able to like stick between the ball and the printed part to maybe like smoothen it up a bit. And I'm thinking also I could add some fabric that I could lube up, and that will smooth things out a bit. But as it is, I'm pretty surprised with how easily the steel ball slides on the printed part. It's really quite good. So for now, I definitely consider this to have a solid and smooth connection. And as we just saw, this design absolutely meets the would be nice requirement of having fewer parts, with a 3x reduction of the old design. So I'm pretty happy with that. Ticks all the boxes. I don't have too many concerns with the design, but one of them is that the magnet on the ball might not be strong enough. If that is the case, and I do find that the platform separates from the legs when it shouldn't, then I can always either get a stronger magnet or just decrease the distance between the magnet and the ball. So I move myself over here. You can see there's a bit of a gap here between the magnet and the ball, and there is a bit of space there for me to reduce that down. If I have the magnet just on the ball by itself, it's very, very strong and works really well. The reason why I don't have just the magnet attached to the ball straight up, and why I have this printed cup part, is so that the magnet doesn't slide along the ball up and down, making it less precise as to where it's actually positioned. And the second concern is that it might not slide easily enough. But I think it's pretty fine, to be honest, and even if it's not, I've got some ideas with the fabric and the PTFE sheet to alleviate that. And there you have it. The new design is so much better than the previous ones. It's fewer parts, it's easier to make, it's better in pretty much every way. And I'm really keen to put this into the actual Jugglebot. I'm still waiting on some carbon fiber tubes to actually be able to make this design. And in the meantime, I'm going to be making a couple more videos on the specifics of how this design has improved on the previous one. You can see pretty easily that there are some big changes between this and this. It's definitely a big step. As always, I hope you found that interesting, and if you have any thoughts or comments about any of this, then please let me know down below. And until the next one, have a good one.